back everyone to another session with the chemistry wizard who loves to share some different and fun ways and techniques to learn chemistry in a very good way. The last time we were here, we discussed about different isotopes and introduced to the periodic table. Today, we are going to continue the discussion on the subject of chemical foundation, atoms, elements, and ions. Dr. Sidhu, how are you today?
Hi, Komal. I'm very much fine today, and I'm so excited to be with you.
Okay, Dr. Sidhu, the last time you introduced us to the periodic table. So, what is the significance of periodic table in learning chemistry?
Oh, yes, of course. So last time we started with periodic table, and I introduced the periodic table, what a periodic table means to a chemistry student, that it is the classification of elements in the increasing order of the atomic number of various elements. But the question is why we need to do that. So I told that time that we need to classify elements because that way it's very easy to understand the properties of the elements. But apart from this, there are few more things which are very important, which can be studied by studying the periodic table. So the first thing is about the charges. We are able to figure out the charges of the various elements about metals, non-metals, and metalloids. Second is we are able to figure out the valence electrons for the various elements and about the valency of the various elements. So valency, valence electrons, charges, we are easily able to understand once we know about the periodic table.
Dr. Sidhu, you just said charges and the valence electron, valency, and so please just briefly explain about these new chemical terms.
Oh, of course. Actually, this is so much important, I'm telling you. Why this is known as the chemical foundation. Our topic is actually chemical foundation. So the valence electron, valency, charges, octet rule, these are very, very important terms. And then the next topics which are coming up about the theories of chemical bondings and all that, the naming, that will be super easy for the students if they are able to get the better understanding of all these terms. So first of all, let me just start with the valence electrons. Valence electrons are the electrons which are present in the outermost shell of the atom. Like, for example, we have the nucleus, and then the electrons are revolving outside the nucleus in a fixed circular path. So those fixed circular path, those are known as energy shells or orbits or energy levels. So the electrons which are in the outermost shell, energy shells, those are known as the valence electrons. So for example, in group number 1, that is lithium, sodium, potassium, rubidium, cesium, francium, which is group number 1. So the valence electrons, that is 1. For group number 2, the elements are beryllium, magnesium, calcium, strontium, barium, radium. So the valence electrons, that is 2. Group number 13. Group number 13 is boron, aluminum, gallium, indium, thallium. So here the valence electrons are 3. For group number 13, that is 3. Group number 14, that will be valence electrons 4. Group number 15, valence electrons 5. Group number 16, valence electrons 6. Group number 17, that is halogen family, that is valence electron 7. And group number 18, that is valence electron, that will be 8. So look, like when we see the periodic table, we are able to figure out if it is silicon, we know it is in group number 14. So we know that the valence electrons will be 4, right? Like krypton. Krypton is noble gas. Noble gas means it is in group number 18, means valence electron, that is 8. Like if it is francium, francium means group number 1. So group number 1 means the valence electron has to be 1. Like iodine. Iodine is a halogen. Even if you don't know the atomic number, because you know iodine is in the halogen group. So it means the valence electrons, that will be 7. So it's very easy. And second part is about the valency. What is meant by valency? Valency is the combining capacity of an element. Then what is a combining capacity? It is the number of electrons which are lost, gained, or shared. So that is known as the valency. But the another question is why an atom needs to lose electron or gain electron or share electron. For that, there is a concept of octet. So the octet rule, it says that every element tries to have maximum of 8 electrons in its outermost shell so that that element can attain a stable noble gas configuration. You know, these noble gases like group 18, these are very stable gases. They do not react like helium, neon, argon, krypton, xenon, radon. These are noble gases. They do not react. Why something won't react is because that is stable. So these gases are stable. That's why they do not react. Now, every element in the periodic table, those elements try to become like noble gases. They are not noble gases, they try to become like noble gases. But how can those elements become like a noble gas is either by losing electron or by gaining electron or by sharing electron. So what do you mean by becoming like a noble gas? It is to have maximum of 8 electrons in the outermost shell, because all the noble gases have 8 electrons in the outermost shell except for helium. Helium is having like 2 electrons. So hydrogen tries to become like helium by gaining 1 electron. Like sodium has atomic number 11. So it is the electronic configuration. Look, I'm using these words, electronic configuration. This is a new term, right? So electronic configuration means it is the arrangement of electrons. We don't randomly throw the electrons in the atom. So there is a proper style of arranging those electrons. So the first shell can have maximum of 2 electrons, then second shell can have maximum of 8 electrons, and the last cell, shell has again 8. So for sodium, like atomic number is 11. So first shell has 2 electrons, then 8. So out of 11, 10 are filled. We are left with 1. So 1 electron. So that is known as the valence electron. So to become noble gas, this sodium is going to lose 1 electron so that now it has the 8 electron. So it will lose electron. Similarly, like halogens, like non-metals, they gain electron or share electron. So that is known as the valency. So it means the atoms actually, they lose, gain or share electrons to attain stable noble gas configuration. Now the question arises, why atoms, they want to be stable? The answer is because stability is the law of universe. Everything in this universe wants to attain stability. It is as simple as that. Nobody wants unstable relationship, right? Nobody wants unstable jobs. Everyone tries to have very stable, lifestyle, their relationship, their friendships, their job. So similarly, here also in chemistry, the atoms, they try to be stable. So you look, our chemistry is basically based upon the laws of universe. All the laws of universe, these are the basis for this beautiful subject, chemistry. So that is why if somebody asks that, why atoms want to be stable? So the simple answer is because stability is the law of nature. Everything in this universe wants to attain stability. So, and then last but not the least, that amount of electrons when they are the elements they are losing or gaining, that time they occupy some charge, right? So that charge we are able to figure out again through the periodic table. Like group 1, all the elements will have +1 charge. Group 2, all the elements will have +2 charge. Group 13, they will have +3 charge. Group 14, they will have +4 charge. Then group 15, it will have -3 charge because they are going to gain electrons, right? And then group 16, that will have -2 charge. Group 17, halogens, they have -1 charge, like general. And group 18, because they neither gain electron, nor lose electron, nor share electrons. So that is why they have 0 charge.
You really are a chemistry wizard. Everything is there on the tips, and you just make it look so easy.
Thank you.
So, Dr. Sidhu, any question for our viewers today?
Yes. So Because I'm talking a lot about elements like metals, metalloids, and non-metals. I know we are dealing with chemicals, and as I told in my one of my previous lectures, also in my session, that uh, we are kind of a chemical factory, right? Inside, outside, it's all chemicals. My question is, recently there is a very deadly metal which is poisoning the water bodies and the soil of our universe, like, our planet. So what is that deadly metal which is creating that poisoning? And there is a plant which is used to remove that metal from the soil because it's very deadly from the water bodies. So what is that plant in nature? The God has given that. Like, again, I'm saying the universe has basically given us that plant. The plant is able to actually remove that deadly metal from the soil and the water bodies. So what is that plant which is able to remove that poisoning, that metal? So that's my question.
I hope our viewers find it and can share the answers with us. Thank you, Dr. Sidhu, for sharing such valuable information. We are going to hold these sessions for your benefit in the future as well. This is, please like and subscribe Dr. Sidhu's Academy on YouTube. This is Koma from Outline Media signing off.